Greetings, this is Mrs. Bird from Advancing Science at Gettysburg College. Today we'll be looking at just how do solutions or mixtures impact the freezing temperature of water. Where do we see this in the world around us? We'll be looking at the freezing temperature of water and ice, water, ice, and sugar, water, ice, and salt, and then finally water, ice, plus birdseed. You can change your birdseed to something else if you like when you do the experiment. First, let's look at our materials. We're going to need 1 tablespoon of sugar, 1 tablespoon of salt, 1 tablespoon of birdseed, Legos, pennies, marbles, anything that won't dissolve in water. 3 small drinking glasses. I like the short ones, that way you can see our thermometer more easily. Water, a spoon for mixing, ice, thermometer, and a tray or newspaper to keep your area dry, because you're going to make a mess. And if you have an older brother or sister, that's actually pretty helpful too. First, we're going to start off just testing water and ice. And we're going to do that simply because we need to have something to compare to. Anytime you do an experiment, you need to have a baseline, which gives you your information of what's normal conditions going to be like. That's our before. And then we can easily compare our afters to that. I've already set up my thermometer in a glass of ice water and let the ice sit there for a few minutes. I've added my thermometer to it, and I'm not going to take my reading instantly. I have to let it sit in the water for a little bit of time. And you'll notice that I hold my thermometer towards the top where the ice is. Now let's take a look at how we read our thermometer. That's probably the most important part of this experiment. Notice that there's 2 scales here, Fahrenheit and Celsius. In our daily life, we use Fahrenheit. In science, we use Celsius. Most of the world uses Celsius for their daily life. We also need to make sure we can properly read the scale of our thermometers. If you look at this thermometer, when we go between the range of 10 to 20, there are 5 hash marks. Each one of those marks will indicate a change of 2 degrees, 12, 14, 16, 18, 20. If we look at the Fahrenheit side, you're going to see the same scale used there, but you can't always be certain of that. 62, 64, 68, 70. Let's take a look and see what's our temperature. If we look on the Celsius side, we're going to see that it is 12, 14, 16 degrees Celsius. On the Fahrenheit side, we are somewhere between 60 and 62. It's so close to 62 that I probably end up reading it as 62 degrees. Now, let's take a look and see what our reading is for our thermometer in just ice water. If we look closely, we can see that it's 0 degrees Celsius, and 0 degrees Celsius is freezing. 32 degrees Fahrenheit, and we all know that 32 degrees Fahrenheit is freezing on that scale. So it seems to be that our thermometer is well calibrated and right on. Let's keep that in mind. You're going to want to record this data so that you have it later for graphing. Make your table, and on that table write water and ice, and make sure you record your units, 32 degrees Fahrenheit and 0 degrees Celsius. Now let's go ahead and prepare our mixtures and solutions. You're going to notice that I have a tablespoon of each of my components. I have my sugar, my salt, and my birdseed. Do you know which one of these is going to be a mixture and which 2 will be a solution? First thing you want to do is make sure we know what a mixture and a solution is. A mixture is going to be made of two or more substances. Think about sand and rocks, pennies and nickels. Here we have assorted candies. That's going to be a mixture. They each have their own identifying properties, and they can easily be separated. I could pull the gumdrops out and leave the marshmallows behind, and all the parts of the mixture keep their original properties. That gumdrop is going to stay a gumdrop. Now when we look at solutions, a mixture is a solution if one of the substances dissolves in the other. We've all made Gatorade or iced tea or lemonade, and it's dissolved. The solute is the substance that dissolves. The solvent is the substance that does not dissolve. In this case, our solvent is water. Okay, the first variable we're going to test is going to be water, ice, and sugar. We've dissolved our sugar, so it's a solution. Water will be our solvent, sugar will be our solute. So as we look at our temperature, you'll notice that I'm keeping the thermometer in the water at all times. I don't want to measure the air temperature. I want to measure the water temperature. I'm holding it towards the top where the ice is. We can see the temperature is dropping. We're going to wait until that temperature stabilizes before we take our reading. On the Celsius side, what's the temperature? It's stabilized, so we can make our reading now. How about the Fahrenheit side? Make sure you record these values in your notebook so you have them available to graph. So, if you noticed, in our last test, we had a temperature below 0, or below 32 degrees on the Fahrenheit scale, meaning we lowered the temperature of freezing. We lowered the freezing point. That was with ice, water, and sugar. Now let's try ice, water, and salt and see what results we come up with. Where else have you seen a combination of ice, water, and salt? Hopefully that truck gives you an idea. They make a solution of ice, water, and salt. They apply it to our roads, and that lowers the temperature at which the roads will begin to freeze if water falls on it. So again, it lowers the temperature at which the roads will freeze. We want that to happen. We want to be able to go out and drive around when it's 32 degrees, and we can do that if we have ice on the roads because it's lowered the temperature to, let's say, 25 degrees before it freezes. Salt disturbs the bonds that water makes, and that makes it difficult for it to freeze. Let's take a look at this image. We have pure water, and at 32 degrees, it'll freeze into ice. But let's say we add something else into the mix. Salt, sugar, lemonade mix, beet juice, pickle juice. It's going to get in the way of forming those hydrogen bonds. Remember, water's made up of hydrogen, oxygen. They bond together to make water. Hydrogen bonds love to join to each other, but if something's in their way, they can't do it. We have to get even colder in order to freeze. Okay, let's test our saltwater solution. I'm going to speed this up, so keep your eye on the thermometer. Are you surprised that we've decreased the temperature even more? And now, our final test. It's going to be a mixture. What do you think? Okay, you've seen me do the experiment. Now it's your turn. Pick a good option for birdseed, do your experiments, check your temperature, and see if you can change the freezing point using solutions and mixtures. Have a great day. This is Mrs. Bird from Advancing Science.